Okay, we've been asked to prove two triangles congruent. That's your question. Triangle ABF and triangle CED. We've been given two bits of information that FE is congruent to BC, so that little bit FE is congruent to little BC, and we know we've got some parallel lines going on. I'm going to draw in those parallel lines. So AB is parallel to ED, and AF is parallel to CD. How are we going to prove this congruent? Well, when you think about this, think about your rules for congruent triangles and think about what information you have. So you've got the rule side, side, side. You've got the rule side, angle, side. You've got the rule right angle, hypotenuse side, and you've got the rule angle, angle side. Do we have three sides? No, we've barely got information about one side. So side, 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 and side angle side are out. Do we have a right angle? No, right angle, hypotenuse side is out. We've got potential to find other angles though, don't we? Because we've got parallel lines. So angle, angle side is definitely our winner at the moment. Okay, so let's think about angle, angle side. Firstly, let's show that we can actually say that we've got a side that's congruent. So I'm going to make a statement in all these proofs, and then next to that I'm going to do a reason. So I'm just going to write it out a bit bigger than we've got here, but let's do statement, reason. That's how we set out a proof. Okay, my first statement is that F B is congruent to EC. Pretty bold statement there, but I'm going to write my reason out here. Well, I know that FE is congruent. That's what this silly swirly thing means with the equal sign to BC. That's given. And I know that FE plus EB equals FB. I also know that EB plus EC equals, plus BC, sorry, equals EC. Okay? So I can make that statement. I've shown that. Now, let's think about our angles. Well, I'm going to draw an alternate angle. So I've got this one, and I've got that one. Okay? And I'm going to draw in this transversal. So this is A, and this is B. And what if you're thinking, where are we talking about? We're sort of talking about this parallel thing going on here. Okay? So the point where we're meeting down here is E, but where we're meeting there is D. And we've got B, sorry, and we've got D somewhere there. Okay. Now if I drew this in real life, hopefully you would scream, oh, okay, we've got alternate angles. Yeah, we sure do. We've got that and that. They're alternate, aren't they? They're equal. That's a property of parallel lines. Those not opposite angles, alternate angles across the line cutting it are always going to be equal. So we therefore know, and remember order is important, ABE, angle ABE, the center letter describes where the angle is congruent to, it's ABF, not ABE, because it's in that triangle. So we're talking about one triangle, so that's a good mistake to make. ABF, because make sure ABF is in the triangle ABF. So angle ABF is congruent to angle CED, again in that triangle, okay? And that, how do we write that? Well, we just put alternate angles. That's all the reason you have to get alternate angles. Okay. Then let's rub out that little thing there. Let's think about our other set of parallel lines going on here. Okay. So I've got another set right here. This is A, and this is F, this is C, and this is D. Now where's I'm cutting here? Well, I'm cutting at F, definitely, and I'm cutting at C, so that's alright. C is going to go for a bit of a holiday now. Okay. So for A and C, that's a really bad diagram. Let's draw it again. Fun. Okay, so that's F, and that's A up there, and that's C at that point in there. Okay. So what's going on? Well, we've proved that ABF in here is the same as that one, so we don't really want to show that again. We'd like to show something with AFB. Okay, this angle in here. I'd like to show something with that. I would also like to show something, I think, with ECD, don't you reckon? Because that's right in here. Ooh, I think we might have alternate angles happening again. You see that? Here's our parallel lines, and here's our angles on either side of this diagonal. So angle, and we know therefore that angle AFB, again stick to the triangle you're talking about when you're talking about the angle, make sure that the letters of the angle are also the letters of the triangle it's in. The angle AFB, I'm going to call that alpha, just to make it easier, is equivalent to angle ECD. Again, that's what I'm going to call that. I'm going to say that equals alpha, and I'm going to say that's given. That's alternate angle. Alternate angles. Okay, so I've got two angles, and I've got a side. So therefore, really just say which triangles are congruent. Well, we know that, let's make sure we order it in the same way as the angles are. So we're going to go angle ABF is congruent. Therefore, angle ABF is congruent to angle, which angles it's congruent to? Well, let's start at D, because that's where no angle was. Then we're going to go to the curly one, E, a little curvy one, to alpha. Triangle ABF is congruent to triangle DEC, and our reason, angle, angle, side, congruent. And that's our proof. And that's what you need to set out a proof. Sorry for a few typos, but they probably helped you understand what was going on. Enjoy proving accurately and mathematically.